Imagine a world where we control the weather, where we can literally dim the sun to cool the earth. Sounds like science fiction, right? But what if this isn't just a fantasy? What if it's our last, desperate gamble against a warming planet? In this episode of the Science Vault, we dive deep into the high-stakes world of geoengineering, the radical idea that we can deliberately re-engineer the planet's climate. Could it be our salvation or our biggest mistake yet? Stay with me. Over the last decades, the climate crisis has gone from future problem to breaking news. Each year, new records fall. Heat waves so intense that entire regions become almost unlivable. Polar air masses wobbling and collapsing, sending Arctic cold into cities that never prepared for it. Storms that form faster, hit harder, and flood places that were never on the map for extreme weather. This isn't a slow-burn crisis anymore. It's a cascade. We've known the solutions for years. Cut emissions, use less fossil fuel, protect forests, switch to renewable energy. And yet, global emissions are still high, and the atmosphere keeps filling up with CO2. So now we face a brutal question. Have we left it too late for normal solutions to work on their own? For some scientists and policymakers, the answer is maybe, and that maybe is what opens the door to something once unthinkable: geoengineering, a deliberate attempt to hack the climate system itself. Geoengineering isn't one single technology. It's an umbrella term for a set of tools aimed at cooling the planet fast. Broadly, there are two main paths: solar radiation management, or SRM, carbon dioxide removal, or CDR. Let's unpack both. At its core, solar radiation management is simple to describe. If the planet is getting too hot because of sunlight being trapped, then let's reflect more of that sunlight back into space. One of the most discussed methods is stratospheric aerosol injection. Scientists propose releasing tiny reflective particles, like sulfur-based aerosols or other materials, high into the stratosphere, forming a thin veil that bounces a bit of sunlight away. We know something like this can work because volcanic eruptions have already shown us. When Mount Pinatubo erupted in 1991, particles blasted into the stratosphere cooled the planet by about ½ degree Celsius for a short time. SRM ideas also include marine cloud brightening, spraying fine sea salt into low clouds over the ocean to make them whiter and more reflective. More speculative methods like reflective surfaces or space-based shades, though those are far from practical. But here's the catch. You're not just changing temperature, you're potentially changing rainfall patterns, monsoons, and storm tracks across entire continents. This is planetary-scale meddling. The second path is carbon dioxide removal, or CDR. Instead of blocking sunlight, CDR tries to pull CO2 back out of the atmosphere. Imagine enormous machines that vacuum carbon out of the air, capture it, and lock it away underground for thousands of years. That isn't fiction. Facilities like Climeworks Orca and Mammoth Plants in Iceland are already doing this today, albeit at small scales. Other CDR ideas include enhanced weathering, grinding up certain rocks and spreading them so they naturally react with CO2. Bioenergy with carbon capture and storage, BECCS. Growing biomass, burning it for energy, and capturing the emissions instead of releasing them. Ocean-based methods, like fertilizing certain regions to stimulate plankton growth, which could lock away more carbon when they die and sink. Unlike SRM, CDR tackles the root cause, greenhouse gas buildup, but most CDR methods are slow, expensive, and nowhere near the scale needed, yet. In the best-case scenario, geoengineering could give us the one thing we're running out of: time. If SRM could cool the planet by even a fraction of a degree, it might slow the melting of ice sheets, reduce the likelihood of crossing dangerous climate tipping points, give vulnerable countries a chance to adapt, relocate, and build resilience. Meanwhile, CDR could gradually draw down the mountain of CO2 we've already dumped into the sky. Projects like direct air capture are seen as one of several tools to help reach net zero and even net negative emissions. In this optimistic vision, geoengineering acts like a temporary brace on a damaged bridge, stabilizing the system while we rebuild with clean energy, better infrastructure, and restored ecosystems. To some scientists, it's irresponsible not to research these tools, because if things get bad enough, future generations might wish we'd done the homework. But every miracle solution has a shadow, and with geoengineering, that shadow is enormous. Let's start with SRM. If we start injecting reflective particles into the stratosphere, we're not just turning down a global thermostat, we're changing the way energy flows through the entire Earth system. Models suggest SRM could alter monsoon patterns that billions of people rely on, regional rainfall, some areas might get more, others dramatically less, the frequency and intensity of certain storms. We might cool the average global temperature, but some countries could be hit with devastating side effects. So if one nation's crops fail because another nation decided to dim the sun, who's responsible? Then there's the ocean. SRM doesn't stop CO2 from piling up in the atmosphere. It just masks the warming. The extra carbon still dissolves into the oceans, worsening acidification and threatening marine life. And what happens if we start SRM and then suddenly stop? The planet could experience rapid, severe warming in just a few years, a termination shock that ecosystems and societies might not survive. Beyond the physics, there's something even messier: power, ethics, control. Who gets to decide the right global temperature? Which country or organization has the authority to launch a planet-scale project? What if one powerful nation decides to go ahead with SRM, even if others object? What if non-state actors, corporations, or even wealthy individuals get involved? Geoengineering isn't just a scientific question, it's a governance nightmare. There's also a deep fear of moral hazard. If we treat geoengineering as a backup plan, do governments and industries feel less pressure to cut emissions now? Do we risk using planetary manipulation as a license to keep burning fossil fuels? Because if that happens, we could end up in a world where we're dependent on SRM just to keep temperatures tolerable. CO2 levels keep rising in the background, and any failure, accident, or political conflict around geoengineering could trigger sudden, catastrophic warming. We'd be living on climate life support. So, how close are we really? Right now, large-scale geoengineering is not happening, but the groundwork is being laid. Research projects like SCOPEX from Harvard explored small-scale stratospheric aerosol tests before being canceled, in part due to public concern and ethical debates. Meanwhile, companies like Climeworks have built direct air capture plants in Iceland, like Orca and Mammoth, as early steps towards scalable carbon removal. These efforts are tiny compared to global emissions, but they signal a shift. We're testing tools that, in the future, could be scaled up dramatically. At the same time, activists, scientists, and indigenous groups warn that geoengineering experiments, especially SRM, could normalize ideas that are risky, unjust, or impossible to govern fairly. So humanity is in a strange place. We might need these tools someday, but using them might create new dangers we can't fully predict. So, where does all of this leave us? On one side, a vision in which geoengineering helps us avoid the worst outcomes, protects millions of lives, and buys us the time we desperately need to transition away from fossil fuels. On the other side, a scenario where we gamble with the climate system, deepen global inequality, and lock ourselves into technologies we can never safely stop. The truth is, we don't know which path geoengineering would lead us down. What we do know is this: we still need to cut emissions fast. No amount of planetary tinkering replaces that. We need transparent, global conversations about these technologies, not just quiet decisions behind closed doors. And we need science that is honest about both the promise and the peril. Because this isn't just about data or models or politics. It's about what kind of species we want to be. Do we accept responsibility and change our behavior? Or do we reach for the most powerful tools imaginable and attempt to rewrite the rules of the planet? Maybe the real question isn't, can we control the climate? Maybe it's, should we? If this deep dive into geoengineering made you think, hit like. It really helps more people find the Science Vault. Share this video with a friend who loves big what-if questions about our future. And subscribe to the Science Vault for more mind-bending explorations of the science shaping our world, from black holes to bioengineering and everything in between. Thanks for watching, stay curious, and I'll see you in the next one.